Now, for question 3, you are going to see something special. But before you see something special, you got to factor the denominator first. Okay, because as of now, it's nothing special. But once you factor it out, you might find something special. Okay, so again, you know your restrictions. X cannot be 3 and -2. And because you see x plus 2 in the numerator and the x plus 2 in the denominator, they cancel each other out. So therefore, it's 1 over x minus 3. So we will graph this, but x still cannot equal to -2. Okay, so that's where the hole is. Okay, whenever you cancel something out, that's how you know, hey, there's a hole that x equals to -2, and you have to find out where the hole is. Can you tell the y value of the hole? If we know the x value is -2, and we are graphing this, so we put 1 over -5. Okay, so -1/5. So therefore, at -2 comma -1/5, there should be an open circle right here. Okay, -2 comma -1/5. That's where you will see the hole. And for the other restriction, x cannot go to 3, that becomes our vertical asymptote. We have our horizontal asymptote at y equals to 0, because you can simplify the expression to just x over x squared, because all the other ones are just too small to be impactful. And x over x squared is 1 over x. You think about x being infinity. 1 over infinity is practically 0. Okay. And then where is our y-intercept and x? Do we have x-intercept? We do. We do have an x-intercept. Where's our x-intercept? Oh, do we have an x? No, we don't have an x-intercept, because we're graphing this, right? We're graphing this, and the numerator cannot be 0. So we don't have an x-intercept. Do we have a y-intercept? That would be 0 comma -1/3. So it will be right here. So in that case, I'm going to connect the dots like this. It's going to plunge to the negative side of the vertical asymptote. And since our denominator is just a simple x minus 3, there wouldn't be any square. So there will be a sign change, and that's when you plug in 0 for x, right? When you find the y-intercept, 0 x value is 0, so put in 0 right here. Then it's just -1 over -3, which is -1/3.
Oh.
Yeah. Yes.
How would you define the hole?
How would I define the hole? Like in words, a hole is simply a value that cannot be defined at that x value. Yeah, because we said the restriction was 3 and -2, right? But since we are graphing this, it would give people a perception that -2 is fine, but we knew from the beginning that -2 will not be fine. So that's why we established this hole as an open circle. Okay. Now, what about f of -10? Now that simply means when the x value equals to -10, in case you don't know. So you just go ahead and put in -10 at our final expression, the 1 over x minus 3. So it's simply 1 over negative 13. Okay, or negative 1 over 13. Now, the domain, okay, this is the part. Now, you will still take the restriction into account when you think about the domain. So x could be anything but 3 and but negative 2. So the domain is going to be from negative infinity to negative 2, from negative 2 to 3, and then 3 to infinity. Okay, so we're just basically translating our restrictions into an interval notation. X cannot be negative 2, x cannot be 3, so we have 3 separate intervals to describe the values of valid x's. And for our range would be from negative infinity to negative 1/5, because there's a hole right there, and then keeps on going all the way to 0 because we don't have any x intercepts here, and then from 0 to infinity. Okay. If you're okay with this, I'm going to go over the other the last page.